Hello friends, today I'm going to solve LeetCode problem number 1637, widest vertical area between 2 points containing no points. Okay, so let's read the description. So here we are given n points in a 2D plane where a point is a coordinate point x, I, y, I. We got to return the widest vertical area between 2 points such that there are no points inside the area. Now what's the vertical area? Vertical area is an area of fixed width extending infinitely along the y-axis, that is infinite height. So basically vertical area means this is a vertical area which is extending infinitely in the y-axis, okay? And widest vertical area is the one with the maximum width. So vertically it would extend to infinity, but we need to get the widest area, and the widest area should be such that there are no points inside the area. There can be points on the edge but not inside the area. So here is a point on the edge and here is one point on the edge. So this is one area and the width is equals to 1 because it's we just subtract the x coordinates of the both points. And similarly in this case also the width is 1. Now we got to return widest one, so basically here the widest is 1, so that's our answer. Let's look at this example. So basically this example is illustrated in this figure. I'm gonna take this example and show it to you how can we actually solve this problem. Okay, so what we have here is we need the widest area, right? The widest uh, vertical area, and the widest vertical area is determined by the x coordinates, right? So if we just can get the x coordinates, we can find the widest vertical areas. So what we need to do is here I'm just going to create an xy axis, and okay, let me just arrange these values. Okay, here I have 1 2 3 4 5 6 7 8 and 9. Okay, so we have 9 coordinate indexes, and now our first x-axis is x coordinate is 3, right? So 3 1, so 3, okay, let's suppose 1 is somewhere here. Then we have 1 point over here, we have 9 0, so 1 point is here. Okay, the next point is 1 0, which it would be x coordinate 1, y coordinate 0. The next we have 1 4, so that would still be x1, and 4 would be somewhere over here. And next is 5 3, so x coordinate is 5, y coordinate is 3. Okay, all right, so that would be somewhere around here. Next is 8 8, so that would be somewhere, let's suppose, around here. Okay, but we need the maximum width. So maximum width we are going to calculate by taking the difference in x coordinates. Okay, so here there are the maximum width we would get is equals to 2. Okay, next here the maximum width is again equals to 2. Here the maximum width is equals to 3, and here the maximum width is equals to 1. So what are we doing here is we're just subtracting the x coordinates, and the x coordinates are subtracted based on in an order, right? So we have 1 2 3, so we are subtracting them in an order. So that is what we got to do. We got to sort this array in sort this array based on the x coordinates in an ascending order, and then subtract the x coordinates from each other and get the maximum value out of them. So that is all we need to do. Now I hope you understood the problem. Let's dive into the solution. So here let's first sort our array based on x coordinate. So since we are sorting in ascending order based on x coordinates, so that would be a minus b, and we are taking the x coordinate which is at index 0, and this will sort in ascending order. All right, now we have ascending order. We need the max width, right? So initially we are going to assign it 0. And okay, let's look at the constraints. The value of the maximum length is equals to n, and at least we have 2 points, and maximum 10 to power 5 points, and the points are of length 2. That is, we have x and y coordinates, and the value of x and y coordinates start from 0 and 10 to the power 9, which means that we only have first quadrant of our plane, that is both x and y values are positive. So since we are sorting in ascending order, we would have all the values in increasing order and positive, right? Like starting from 0, we will have the values in increasing order, and we just got to subtract the second value with the previous value. Okay, so now what we are going to do is, starting from let I equals to 1, I is less than points length I plus plus. So here max width. Okay, so I'm updating the max width, and that should be the maximum of max width, or the difference between current point at index 0 minus the x coordinate at previous point. Okay, and why am I starting from index 1? Because we are comparing point at that given index with previous index, right? So 1 minus 1 would give us index value 0, but if we start from 0, this would be negative, and we do not have any negative points, so that's why we are starting from index 1. All right, and finally we are going to return our max width. So this will give us our results. Let's now try to run this code. Awesome, let's submit this. And now talking about time complexity, since we are sorting our points, so that would result in log of n time complexity. So n log of n, and the for loop is n time complexity, so our overall time complexity is n log of n. And talking about space complexity, we are not using any extra spaces. However, the sorting function itself occupies some space, and basically that would depend on the implementation of sort function. So if it is merge sort, then it would be log O of n time O of n space complexity for merge sort. Okay, and if it is quick sort, then that would be log of n space complexity for quick sort. Okay, so yeah, that's all about this solution. I hope you liked my solution. Let me know in the comments down below, and please like my videos and subscribe to my channel for more such videos. Thank you.